So what's the utility of these diazonium ions? Why do we care about them? Why are they useful? Well, with alkyl amines, let's take a look at what happens. If you take an alkyl amine and subject that to nitrous acid, you will form the diazonium ion. But what you should immediately see here is that N2 plus is essentially nitrogen gas attached to the molecule. And what's going to happen here is very, very rapidly, you're going to lose nitrogen gas. So that will act as a leaving group. You'll end up with a carbocation plus nitrogen gas and Cl minus. And then what can happen with this carbocation is substitution and elimination reactions. So this could go to the SN1 product with the Cl minus. It could go to an E1 product giving a double bond. Essentially, not very useful. If we want SN1 and E1 products, we have much simpler ways to do that. With an arylamine, however, we're going to get a similar initial reaction where we form the diazonium ion. The difference is this diazonium ion is actually stable at low temperatures. So unlike the alkyl diazonium, which rapidly decomposes, this you can hold as a diazonium ion for a while. Why is that? Well, you know the answer to this. If you were to lose nitrogen gas from this, we would end up with a carbocation on a double bond, which is very unstable. So instead of doing that, this will just hang out as a diazonium ion. So still, why is this useful? Well, what this can essentially do is act as a leaving group for substitution reactions at the aromatic ring. And in fact, there's a variety of different reactions we can do, which really opens up the various possibilities. So here is our aryl diazonium ion, and we can see how many different things we can convert this to. If you add water to that, you can convert it to an OH. Copper nitrate will convert it to an NO2, copper bromide to a bromine, potassium iodide to an iodide, copper cyanide will convert it to a CN, H3PO2 will convert it to a hydrogen, and we're going to see why that's useful. You may not think initially that's very useful to just convert this back into a hydrogen, but when we do synthesis, we're going to take advantage of this reaction right here. Copper chloride will convert it to an aryl chloride, and HBF4 will convert it to a fluoride. So in addition to halogens that we've already done, like Br and Cl, this opens up ways to get iodides on the ring and fluorides on the ring, as well as some other groups. So the diazonium ion chemistry opens up a lot of synthetic possibilities for us. This particular chart of reactions is not something I'm going to make you memorize. I will give you this chart on the exams.